All right, let's dive into this absolute beauty of a galaxy, Messier 100. I mean, just look at it. From where we're sitting, it seems like this perfectly serene, swirling masterpiece in the cosmos. But as it turns out, new research is showing us a much, much more chaotic story, one filled with violent starbirth and some really mysterious rogue elements, all hidden inside those graceful spiral arms.
So just to get our bearings, M100 is hanging out in the Coma Berenices constellation, inside the gigantic Virgo cluster of galaxies. Now it's about 50 million light-years away. To put that in perspective, the light that we're seeing from it tonight actually started its journey right around the time our mammal ancestors were first starting to take over the planet. Kind of wild, right?
You know, astronomers have a name for galaxies that look this perfect. They call it a grand design spiral. And yeah, you can see why. It has these gorgeous, prominent, really well-defined arms. It's like a textbook example of galactic perfection. But as we're about to find out, once you zoom past that pretty picture, you find a place that is way more complicated and dynamic than you'd ever guess. Okay, so to really see what's cooking, we have to start our cosmic zoom in. We're going to blow right past those huge outer arms and dive deep, deep into the galaxy's core, because that's where we find this powerful and pretty unique engine that's driving all the action. Now, this is what's so fascinating. M100 doesn't just have one bar of stars and gas running through it, it has two. You've got the big outer bar that kind of gives the whole galaxy its general shape, but hidden inside of that is a second, much smaller nuclear bar. And you can think of this tiny inner bar as this powerful little engine just stirring things up right at the very heart of the galaxy. So this nuclear bar, it basically acts like a cosmic conveyor belt. Its intense gravity grabs onto all this interstellar gas and just yanks it out of its normal orbit. As that gas loses momentum, it starts to spiral inwards, funneling a huge amount of material directly toward the galactic nucleus, and that provides all the raw fuel for what happens next. And all that gas being channeled inward, well, it has to go somewhere. The result? It's absolutely spectacular. It kicks off this incredible storm of creation, but in a surprisingly delicate pattern. For the longest time, our early infrared observations showed that, well, something was going on in a ring-like shape around the nucleus. You could see these bright, kind of blurry hotspots of light, but the view was just too fuzzy to really understand what they were or, how they got there. But then, with the power of our newer, high-resolution telescopes, we can now see what those blurs really are. And it's this: a fiery necklace of new stars. What looked like just a smudge is actually a collection of 43 separate, compact regions of incredibly intense star formation, all wrapped beautifully around the galaxy's core. And when you analyze the light coming from these little knots, you find something astounding. These are incredibly young starbursts. This entire flurry of star-making happened within the last 15 to 25 million years. Now, in the life of a galaxy, that is just the blink of an eye. It's happening right now, cosmically speaking. But as scientists zoomed in even further, they found something else. Something that just, well, it didn't fit this nice, orderly picture of a bar-driven system at all. It was a complete surprise, and it totally challenged their models of how this galaxy is supposed to work. So, while a research team was mapping out where all the atomic hydrogen gas was in the galaxy, they stumbled on something really strange. They found two rogue clouds of hydrogen that were completely out of sync with everything else, moving in a way that just defied the galaxy's smooth, predictable rotation. These two maps really lay out the mystery perfectly. The first one on the left shows us where the gas is. And yeah, it's physically close to the galaxy's disk, right where you'd expect. But the second map, the one showing velocity, that's the kicker. It reveals the gas is moving about 40 kilometers per second off from everything around it. It is literally like seeing a car going the wrong way down the freeway. It just doesn't belong. So, this discovery immediately raises a huge question for astronomers. What kind of powerful event could possibly be responsible for creating these bizarre, detached clouds of gas that seem to be just marching to the beat of their own drum? Right now, scientists have three main suspects. First theory, all that intense star formation led to powerful supernova explosions that literally blew the gas right out of the disk. Second is something called ram pressure stripping. You can think of it like a cosmic headwind that's peeling layers away as M100 speeds through the gas of the Virgo cluster. And the third idea is a past gravitational dust-up, a close flyby of a smaller galaxy that could have pulled these streams of gas loose.
And that brings us to the final big picture piece of the puzzle. We need to zoom back out and stop seeing M100 as just this isolated object. We need to see it for what it is, a citizen of a vast and very crowded cosmic city, the Virgo cluster. And living there has some serious consequences for its future.
See, because it lives in such a dense galactic neighborhood, M100 is probably going through something astronomers call gas starvation. Basically, the intense pressure and gravity from the whole cluster is stripping away the cold gas in the space around the galaxy, cutting off the external fuel supply it needs to keep making new stars. So those intense starbursts we see lighting up its core, yeah, that's not a sign of eternal youth. It's actually the galaxy furiously burning through what's left of its internal reserves. Without a fresh supply coming in from the outside, it's speeding up its own transition from a vibrant star-forming galaxy to a dormant, red and dead one. And this really matters because M100 is giving us a ringside seat to watch this exact transformation happen.
So when we look up at Messier 100, we're not just looking at a pretty static picture. We are watching a snapshot of galactic evolution in action. We might just be getting a glimpse of the final, brilliant burst of activity before a magnificent galaxy slowly fades away. It's a beautiful, violent, and ultimately finite story, written in the stars, telling us how these cosmic cities live and how they die.